Well, here we go again. All right, we're still in Unit 9. This is Day 5 homework. Day 5 homework. But we got to learn the notes first. And today we're going to be talking about cosine equations with multiple functions. I don't know. Can you see me now? Can you see my hands? I don't know. Let's see. I don't know. What can you see? All right, here we go. Unit circle. Unit circle. It's called the unit circle. It's called the unit circle. I don't like that. Let's erase that. I don't like that. Let's erase that. It's called the unit circle. It's going crazy. It's called the unit circle. Let's see if I can hide that. Because, for a very simple reason, that the radius of this circle is 1. So I know the radius is 1. Woo! Radius 1. Okay, now, if you remember correctly, we've talked about this a bunch. This x value, this x distance along here, you know, the coordinates of this point, the x value is represented by the cosine. So the cosine of, let's say, theta. So the cosine of theta is the x value. And the sine of theta, I hope that pen gets better writing because this is awful. See the pen? Not working very good. Put it in my gut. Oh, there it is down in my belly. I have no idea what that's going to look like, but that's kind of cool. Let's see if it works. So the x value is represented by the cosine of theta. And the y value is represented by the sine of theta. Okay, fantastic. So what? Who cares? Woo! Look what we got going on. Something I know that you all love to do. It's kind of one of those things you're just like, I got it. I got it. I know what this is. I know what the Pythagorean identity is. I know what the Pythagorean theorem is. If I see a right triangle, there's only two things I'm going to think about. Either sine, cosine, or tangent. Sokotoa, some old horse caught another horse, taking oats away. Some old hippo caught another hippo, tripping on alligators. Whatever you use. Or I'm going to use the Pythagorean theorem. And that's what we're going to do today. We're going to learn a few Pythagorean identities. You got to learn the basic one first. Now, let's think about this. If I'm given a right triangle, let me just draw a little right triangle here for you. If I'm given the right triangle, this pen and my drawing is not good right now. That should be a right triangle. And I know that the hypotenuse is 1. This lower value is cosine of x, as represented by this drawing over here. And this y value, or this vertical value, is the sine of x. Well, or theta, whatever. I'm going to use theta, actually. Then, if I'm doing the Pythagorean theorem, doesn't that mean that, the sine squared of theta plus the cosine squared of theta must equal 1 squared, or just 1? Of course it does. That is your first Pythagorean identity. You need to know that. It's going to help solve different problems. Since I don't need this squared, I'm going to get rid of it. So later on, as we work through these, I'm going to say, you know, you're going to come across the number 1 sometime in an equation later on, and you're going to actually replace it with cosine squared plus sine squared, or sine squared plus cosine squared. It doesn't matter what order you do. That is a huge, that's number 1 in our huge topics for today. But we're really not going to use this one too much. You'll see why when we're solving equations, why we don't use this one. When we do proofs and we start trying to prove one side is congruent to, or equal to another side, we're going to use this. But for solving equations, this isn't that useful. So we're going to use modifications of this. And so let's see. If I had sine squared theta plus cosine squared theta equals 1, and I just wanted to know what sine squared theta is, wouldn't I just move that over to the other side by subtracting cosine squared theta, subtracting cosine squared theta? You're all nodding your head, of course, of course. Otherwise, why would you be bothering? Why would I bother to tell you this? It's just what it is. You got it, right? So, wait, I'm not done yet. So, therefore, number 2 in our very important things to know is that sine squared theta is equal to 1 minus cosine squared theta. Now, I don't know why. I've always found out that kids, or I've always found that kids just, they have a hard time remembering this one. Well, I don't ever remember that one. I always remember the original, this one, because I can clearly move cosine over there. Just move it. Oh, when it goes over there, it changes its sign. It's 1 minus. So if I remember sine squared theta plus cosine squared theta is 1, then I can get the other 2. And I say other 2 because it should become very obvious then that the third one we're going to work on is just learning that cosine squared theta is equal to 1 minus sine squared theta. And that should be pretty obvious. I hope. So there's your 3. Those are 3 things you need to know. Now, again, I like just the first one and going, oh, yeah, wait, I need to know what sine squared is. Move the cosine over. Move the cosine squared over. Oh, yeah, sine squared is equal to 1 minus cosine squared. Oh, I need the cosine squared. Well, let me move the sine squared over. Okay, no problem. Now we are going to do a little bit of, let's see if I can do this. Little bit of magic is going to take place on this side. On this side. We're going to do a little bit of magic. You guys like magic, right? All right, let me start with this basic principle that sine squared theta plus cosine squared theta equals 1. Now, you got to bear with me a little bit. Let's get some Hilton colors in there. Let's get some red. You got to bear with me for a minute. What I'm going to do first is I'm going to divide this side by cosine squared theta. Why? Because I want to. You got a problem with it? Oh, you do? I'm sorry. I'm just going to do it. I'm doing it. But, and yes, you know this, if I do something to one side, I absolutely have to come over and do the same exact thing to the other side. Yes, you have a question? Why would I do that? Oh, because I'm going to find some more Pythagorean identities. I'm going to use my original Pythagorean identity, the one that kind of makes sense based on some of the things that we've done already in class, and we're going to find some other ones that are going to be useful. Is that okay with you? I hope so. Okay. I don't like the way this looks, so what I'm going to do is I'm going to split it up. I'm going to make it sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. Now that's legal because, you know, when we add fractions, since we've been doing that a little bit lately, you keep the denominator and add the numerator. So if I want to split them, I keep the denominator and split the numerators, just like that. Okay. Now we have to remember some things that you learned a long time ago. What did we learn that sine over cosine was really equal to? Think about it. Go way back, brain. Get back there in the back of your brain. Oh yeah. I remember. Sine over cosine is really just tangent of theta. Well, in this case, it'll be tangent squared of theta plus, well, this should be very difficult. Cosine squared over cosine squared is just 1. And then I got to remember, this is really what? What is the reciprocal of this? What is that equal to? And if you remember correctly, that's secant squared theta. Oh, yeah. That one's going to have to be memorized for later. Oh, yeah. I don't like the fact that I drew that line over that other line, so that's kind of embarrassing. So this is going to be number 4. Roman numeral 4. Let's do a little more magic. Someone's probably figuring it out already. If you're smart. I don't know how many smart kids I got. I got some pretty smart kids. I was telling somebody the other day, I really, really like teaching trig. You guys are doing so awesome. Well, not all of you, but most of you are. And the rest of you are going to come along. Eventually, I will whip you into shape, and you'll be amazing trig students. Either that, or you'll just do enough to get by, which some of you love to do. I don't know why. 1, oh, we know this is equal to 1, correct? Well, someone in the back of the class I know has just said, hey, why did you divide by cosine? You're not really showing sine any love. Let's show sine some love. We're going to divide by sine squared theta. That shouldn't come as any surprise. And to skip a few steps, I'm going to just take each one of these and divide by sine squared theta. I like skipping steps every once in a while. Hopefully you understand. I've really just divided both sides by sine squared theta. That I have to do. What did you do to one side? You have to do the other. Oh, well, sine squared theta, isn't that just 1? Plus. Now, if sine over cosine up here was tangent, what's cosine over sine? Ah, you got to remember, that's cotangent squared theta is equal to 1 over sine squared is cosecant squared theta. Ah, and that, my friends, is numero 5. I'm thinking flashcards. I'm thinking flashcards. I'm thinking flashcards. Start making them now. Well, let me just tell you this. Right now, we're going to use all of these. Next week, we'll tackle this side. But since I've only got, not a lot of time this week, I'm just going to tackle the sine squared theta plus cosine squared theta equals 1. So, here's how it works. You get a problem, and you just stare at it. And you stare at it. And you stare at it. And nothing comes to you. And you stare at it, and you stare at it, and stare at it, and you're like, how do I start this problem? What do I do? I don't know what to do. I don't know. I'll just write some stuff down. Hopefully I can get my homework checked. No, guys, come on, man. Ooh, that used to be like a commercial or something. Come on, man. What you got to do is you got to look to replace things. You got to look to make some substitutions. Get rid of some stuff that we know we can get rid of. And for tonight's homework, we're just going to be using the regular old Pythagorean theorem, sine squared theta plus cosine squared theta equals 1. So, here's how it works. I'm going to replace sine squared theta with what I know. Because I know that sine squared theta is really 1 minus cosine squared theta. And when I do that, what you're going to see is that I now have an equation with just cosine in it. And I'm a lot more comfortable with that. I really am a lot more comfortable with that. I got all cosine in there. So, I replaced it. Now let's just start distributing and start moving stuff over. And then nothing's new. Distribute the 4. I get 4 cosine squared theta plus 4 cosine theta equals 5. Now, it's a quadratic. And since it's a quadratic, we're going to move everything over to one side to make it equal to 0. Well, right here, I'm looking at this right in this area, and I'm thinking, my squared term is negative, so I'm going to move that over. So I know I'm going to move everything to the right side. So I'm going to have a 0 on the left side. I'm going to move this cosine squared theta over to the right side, so that becomes 4 cosine squared theta. I'm going to move this over to the other side. That becomes minus 4 cosine theta. And then I'm going to subtract this 4 and bring that over and get 1. Now, I'm really subtracting 4 from this 5, correct? And I get 1. Well, that's not a problem. I can factor that. That's pretty easy to factor. As a matter of fact, it's quite simple. 2 cosine theta. 2 cosine theta. That gives me my 4 cosine theta. I need a 1 and a 1. Oh, wait a second. This is a plus 1. Plus 1, I apologize. That means the signs are going to be the same, and since this is a negative in the middle, they're both going to be negative. Well, that just means they're the same. This is a perfect square trinomial. Awesome! That means here I get cosine theta equals 1/2, and here I get cosine theta equals 1/2. I'm not going through that simple thing of setting it equal to 0 and moving stuff over. I think you can handle it. Well, since they're the same, I don't really have a lot of work to do. Cosine is positive in the first quadrant and the fourth quadrant. So therefore, my two answers are, wait a second, you ought to know this. What theta value, when I take cosine of it, gives me 1/2, and you should know that's 60 degrees. Therefore, my two answers are 60 degrees, and in the fourth quadrant, 360 minus 60, or 300 degrees. All right, we're going, we're moving, we're flying, we're doing, we're basking, whatever. I don't know what I'm going to say. So, notice I have this squared term. You're going to look for the squared term. Originally, you're going to start looking for the squared term to replace. So I'm going to replace cosine squared with 1 minus sine squared. Remember, it's cosine squared plus sine squared equals 1. Or sine squared plus cosine squared equals 1. So if I want to replace cosine squared, I'm going to move sine squared over, which gives me 1 minus. So I get 3 times 1 minus sine squared theta plus 2 sine theta minus 1 equals 0. Distribute, I get 3 minus 3 sine squared theta. Catch up! Dude, seriously, you're falling behind. Catch up. You're slowing down. Come on. Pause it if I'm going too fast. Pause it. Make sure you pause it when making a funny face like... Pause it. Pause it and do a screenshot. Uh-oh. Somebody's texting me. I just got my Star Trek. Did you hear that? That was so cool. By the way, if you call me, Star Trek plays. I'm kind of a Trekkie. So, 0 equals... Oh, yeah. I'm moving everything over to the right side. So, because my x squared's negative, or my sine squared's negative. So, I'm going to move this over. It becomes positive 3 sine squared theta. Move this over, it becomes negative 2 sine theta. And let's see, if I put 3 and negative 1 together, that makes 2. But when it goes to the right side, it becomes negative 2. I'm not really going to show that work. I think you got it. So we get 3 sine theta and sine theta. That gives me my 3 sine squared theta. I know I need a 2. That's interesting. I did that wrong. My answer key's wrong, which bothers me. I need a 2. I need a 2. So how am I going to get a 2? Did I do this problem wrong? Oh. That was just telling me my Google Plus things. Let's think. Let's think. This is embarrassing because I made the answer key up and now I'm embarrassed because I don't know. 2 and 1. I need a 2. So I make this 1. I make that 2. That doesn't make sense. 3 sine theta, 3 sine theta. That's a minus 2. Minus 3 and plus 1. Am I doing something wrong, kids? I'm getting upset now. 3 minus 1. 2 sine theta minus 1. You see me sweating? 3 minus 3 sine squared theta plus 2 sine theta minus 1. Those move over. This was a positive 2. When I brought it over, it becomes negative 2. Well, I'm just thinking, if I put, let me just throw it in here, because my brain, you guys remember, I got up at 2:30 this morning. I'm a little tired. I might have screwed up making this sheet. That's 6 and 1. That's not going to work. If I make this 2 and I make this 1, that gives me, all right, let's just change this to a 1. I'm just going to change this to a 1, change it to a 1, change it to a 1, change it to a 1. I think this is going to work out nice and neat. Let me get rid of this crap, crap, make them all 1s. I will make that change in just a second. 1, 1, 1, and let's see, then I want to have positive 1. So if I want to have positive 1, I need a positive 1 here and a minus 2 here. And that kind of works out nicely. This one gives me, all right, let me show you, because I think some of you are sitting there going, where's he getting those things? Let me go 3 sine theta minus 2 equals 0. I add the 2 and bring it over, and I get 3 sine theta equals 2, and then divide by 3, and I get sine theta equals 2/3. And then this one, I'm not going to do it. It's just sine theta equals negative 1. I draw my picture for this. There's my sine curve. And it equals negative 1 down here at 270 degrees. You should know that by now, I hope. For the other one, I'm going to need my calculator. So let me get my calculator out. And I click on that. And I know I'm going to, oops, click on that. I know I'm going to need inverse sine. I just don't know which. Inverse sine of 2/3. So 2 divided by 3 equals 42 degrees. So this is theta equals 42 degrees. Now, so my answers are 42. Sine is positive in the first quadrant. Sine is also positive in the second quadrant, 180 minus 42, or 138 degrees, and 270 degrees. I don't think I'm going to remember to make that change, so let me do this. I think that's where it is, right? 1. Oh, why do I put a 1 there? I don't need a 1. Just get rid of it. And we'll hit save. And I'll go back. So now, oops, got to print it, because otherwise I'll have a messed up copy. Good. Oops. Outside the margins. You should hear my printer go in a second. I don't know what just happened. Oh, it printed it over here. Gotta do Control P, and I gotta change. What the heck? Cancel. File, print, and send it to my printer. There we go. All right, we're good. That was kind of a brain fart. Sorry about that, kids. I don't know, my printer's not awake yet. All right, so let's work. Let's see what we got here. We're going to replace this sine squared with 1 minus cosine squared. So this becomes 6 times 1 minus cosine squared theta plus 7 cosine theta equals 8. Eventually you're going to get the hang of this and it won't be any problem. You'll understand it. But for now, if you need to see every example, kind of go through every example. Don't skip. Distribute the 6. I get 6 cosine squared theta plus 7 cosine theta. I hope I don't have any more mistakes. Like I said, I've been up since 2:30 this morning. I don't know who. I'm going to blame somebody. I'm going to move everything to the other side. Let me get my other color. So I'm going to move this over to the other side. So it becomes positive 6 cosine squared theta minus 7 cosine theta. And when I subtract this 6 and I subtract this 6 and bring it over, I get plus 2. Let's make sure that looks like what I have over here. That looks pretty good. So 0 is equal to, let's factor this puppy. I know it's probably going to be 3 cosine theta and 2 cosine theta. I know some of you aren't loving the way I factor, but don't care. Let's see. They both have to be the same sign because this is positive, and they both have to be negative. And I need to come up with 7. Well, if I put the 2 here and the 1 here, I get 3 on the outsides and 4 on the inside. There's my answer. 0 is equal to, this gives me cosine theta equals positive 2/3, which I did not want to have come up again, but lo and behold, there it is. And this one gives me cosine theta equals 1/2. And since we're going to cheat, we're in the mood for cheating, Cosine of 2/3, we already did that up here. It was 42 and 138. It was 42 degrees, so it's 42 degrees and 138 degrees. And we know that the cosine of the cosine of 60, the cosine of 60 is a half. I don't know where my mouse is. The cosine of 60 is 1/2, so this is 60 degrees. And we also know that cosine is positive in the fourth quadrant. That's 300 degrees. Perfect, perfect, perfect. Let me grab a different color. How about green? Green's kind of festive. I'm wearing green. Can you tell? I don't know how good this is going to come out. I hope it comes out good. I hope it comes out good. It'll be great. All right. It's all for you. All right. I'm going to get rid of this cosine squared. So I'm going to replace that with 1 minus sine squared theta. Again, if you get it, move on. If you don't get it, stick around. We'll have some fun. I don't have any coffee. You know why I'm not drinking any coffee? Because it's like 8:18 at night. And so some of you are like, oh my gosh, half the night's still around. No, it's almost my bedtime. In fact, I'm old, so I go to bed early. I'm sorry, I forgot the -7 here. So all I did was replace the cosine squared with 1 minus sine squared. Not a big deal. Distribute. All right, we'll distribute 15 minus 15 sine squared theta plus 2 sine theta minus 7 equals, that was some sick writing right there. Amazing. I am going to move all of this stuff to the other side. So that means 0 is going to be left on this side. And I will have 15, positive 15 sine squared theta minus 2 sine theta. And this 15 minus 7 makes positive 8. But when I move it over to the other side, I get negative 8 equals, oh, and we already have equals 0. That looks good. Just want to make sure it looks up. I didn't do anything stupid. So, I'd hate to pull a mistake. Pull a mistake. It's late. I don't know what I'm saying anymore. If anything rolls off my tongue that's like inappropriate or ridiculous, you just let me know about it. I'm sure I'll ignore you. Let's see. I need to come up with 2. I need to get 2 somehow. Or actually, excuse me, negative 2 somehow. So I'm going to assume it's probably got to be 4 and 2. If I put the 4 here and the 2 here, this is 20 and 6. That's not going to give me what I'm looking for. So why don't we just quickly squitch them? Let's squitch them. We'll quickly squitch them and put the 4 here and the 2 here. And that's 10 and 12. Perfect. And since I want them to be negative 2, I got to do negative and a positive. Perfect. This one gives me sine of theta equals 4 over 5. There's only a certain number of fractions we can come up with. This one gives me cosine of theta equals 2/3. My gosh, if I get another 2/3, I'm going to go crazy. Did I already get 4/5 somewhere? No, I didn't. Thought I did. All right, no, I didn't. So, if I go over to my calculator and I do inverse sine, are we on sine? Inverse sine of 4 divided by 5, I get 53 degrees. Theta equals 53 degrees. And there's a few of you like, oh, I already know 2/3. There it is. It's 42 degrees. Wrong-o, kid. Not 42 degrees, because that's cosine. We have to do sine. Although it is 2/3 again, which is kind of annoying, we're still going to do inverse sine of positive 2/3. Hold on a second. Did I just screw something up here? Oh, I am so embarrassed. It is 42 degrees. Oh, wait. No, this is cosine. Why do I have cosine? This is sine. Oh. Woo. Let's try this again, my kids. I need to go to sleep. In this case, I apologize. We're still at sine. So sine of theta is 2/3. And yes, we're going to end up with 42 degrees. Let me finish this off, and then I'm going to go fix the problem I screwed up in a few seconds ago. So my answers are going to be sine is positive in the first and second quadrant. So we'll do 53 degrees and 127 degrees. This is 42 degrees, but it's in the third and fourth quadrant. So I'm going to add 42 to 180 and get 222 degrees. And I'm going to subtract it from 360 and get 318 degrees. Now let me show you where I screwed up. Let me go back over here. Do you remember when I said, oh, we already did this and we got 42 because I was being lazy? Being lazy just bit me right in the behind, because I did cosine of 2/3 there, but the 42 degrees was sine of 2/3. So what I really need to do is stop being lazy, get over to my calculator, and stop making dumb mistakes. It's kind of late. I'm kind of tired. No excuses. Let's get over to the calculator. We need to do inverse cosine of 2 divided by 3. And if you caught that, bravo for you. You're amazing. Whoa, that's 48.2 degrees, or 48 degrees. Cosine of 2/3 is 48 degrees. I think I screwed up on my answer key too. You know what's funny is on the answer key, oh my gosh, it's going to be a late night. So 48 degrees will work. And cosine is positive also in the fourth quadrant. We take 360, subtract off 48, and we get, let's see, that's 312 degrees. I want to apologize. That's embarrassing. Let's see if I can not make another mistake. Dumb mistakes, dumb mistakes. These we already know. These we've worked with. There's the 3 double angle formulas for cosine. And then we've got the 1 double angle formula for sine. And we're going to use those. So what we're going to do now is we're going to make a substitution using the double angle formula first. We might have to also sub in using the trigonometric identities from before, but I don't think so. I don't think so. Let's see how we do. I don't see any squares. Actually, I don't think I see any squares in any of these problems. Ah, that makes things nice. So here's how it's going to work. There's cosine of 2 theta. And I have cosine of theta right there. So I'm going to replace this cosine of 2 theta with this one, because it's got cosine in it. So when I replace it, when I get rid of this and I replace it with what it's equal to 2 cosine squared theta minus 1. And then I'll just write the rest of it. Plus cosine theta plus 1 equals 0. All right, let me clean it all up. 2 cosine squared theta plus cosine theta. And -1 and +1, they just cancel, equals 0. I'm really going to try to stop screwing around so much. I think that's where I'm making my mistakes. All right, let's factor out the GCF. Look for GCFs. There's going to be a lot of GCFs in this section. Let's take out a GCF. In this case, it's cosine of theta. And I'm left with 2 cosine theta. Don't put nothing there. Plus 1. Don't forget, it's there. Done with the factoring. That's all she wrote. So we're in pretty good shape. This one gives me cosine theta equals 0. And this one gives me 2 cosine theta plus 1 equals 0. I'm just going to set those up real quick. This one will end up being cosine theta equals -1/2. Okay, so let's see. I haven't seen this in a while. Let's get these zeros. So cosine curve looks like this. It's got zeros at 90 and 270. So those are my first two answers, 90 degrees and 270 degrees. I also know that this reference angle for 1/2 with cosine is 60 degrees, correct? So therefore, oh my God, it's going to be a late night. I screwed up my answer key again. I got to change my answer key up. But I'm in the second and third quadrant because that's where cosine's negative is, in the second and third quadrant. So this is going to be 120 degrees and adding 60 to 180 at 240 degrees. Okay, so in this case, I'm going to replace cosine 2 theta. I want to replace it with something that will help me since I have a sine already. And I'm thinking, oh, let's replace it with this one. We're going to replace that one in there. So instead of cosine 2 theta, I'm going to get rid of it, and I'm going to replace it with 1 minus 2 sine squared theta. And then I'll copy everything else down, plus sine theta equals 0. I'm going to move everything to the right side because I don't like having negative sine squareds. So I'm going to have 0 equals 2 sine squared theta plus, one of those nights, when I move, I should show you what I'm doing. When I move this over, it becomes negative sine theta. And when I move this positive 1 over, it's going to become minus 1. I have a quadratic. Quadratics need to be factored. Probably right in front of my head. So I'm going to factor this into 2 sine theta. And since it's 1, I know the ends have to be 1, and sine theta. This has to be a 1, and this has to be a 1. Since I want them to add up to negative, I'll put the minus here and the plus here. Hopefully you're getting that. This one here gives me sine theta equals negative a half, and this one gives me sine theta equals positive 1. And in an effort to save time, I know that my reference angle is 30 degrees here. Sine is negative in the third and fourth quadrant. Cosine equals 1 at 90 degrees, so I'll put that one in there first. The reference angle in the third quadrant of 30 degrees is 210 degrees. And the angle in the fourth quadrant that has a reference angle of 30 degrees is 330 degrees. Again, if I'm moving too fast, slow it down, pause it, figure out what's going on. Here's the thing I want to get rid of. Now, this one's kind of funky. We're going to get rid of this one. I only have one option for sine of 2 theta. There's only one. It is simply 2 sine theta plus, oh, not plus, 2 sine theta cosine theta plus, and copy everything else down, sine theta equals 0. Remember what I said, you're going to replace, start either factoring if it's a quadratic, or start looking for a GCF. And in this case, there's a GCF of sine. So I'm going to take sine theta out, and I'm left with 2 cosine theta plus 1. Let me show you what I'm talking about. When I take that sine out, it's gone here. I'm left with 2 cosine, and I'm gone here, and I'm left with this 1 sitting in front there. All right. So this one gives me sine theta equals 0, and this one gives me cosine theta equals negative 1/2. Do you see how these things keep coming up over and over again? So what I was telling you about learning these reference angles and the angles where it's 1/2, square root of 3 over 2 and all that stuff comes up over and over again. So let's see, sine is 0 at 0, 180, and 360. Let's see. Nope, we're not including 360. So 0 and 180. Cosine is negative in quadrants 2 and 3, and again, my reference angle is 60 degrees. So 180 minus 60 is 120 degrees, and 180 plus 60 is 240 degrees. One last problem and we're done, kiddies! Woo! Amazing. Amazing. So, let's see what we're going to do. I want to get rid of this cosine of 2 theta. I have a cosine theta in it, so I'm going to replace it with the one that has cosine in it. That's this one right here. I'm going to replace it with the one that has cosine in it. So, let's come down. I'm going to write it as 3 times 2 cosine squared theta minus 1. Make sure you got the right one. There it is, 2 cosine squared theta minus 1. and then copy everything else down. Plus 5 cosine theta plus 2. We're getting rid of this. Everything else gets copied down. So notice that's the thing that went in parentheses. When you substitute using parentheses. All right, 6 cosine squared theta minus 3 plus 5 cosine theta plus 2 equals 0. All right, let's see. We got 6 cosine squared theta plus 5 cosine theta minus 1 equals 0, because when I combine the minus 3 and the positive 2, I get negative 1. We are almost done. I will make your life easy. If you want to try this on your own, pause it right now. Got my pen? Can you see the pen? See my tie? I don't know what you can see. We're going to find out in a few minutes what you can see. So this gives me, I'm just going to do this, 6 cosine theta and cosine theta. Now the reason I picked that is because 6 and 1 kind of make 5. Since I want a positive 5, I'm going to put the plus 1 here and the minus 1 here. This one gives me cosine theta equals 1/6, and this one gives me cosine theta equals negative 1. All right, well, I don't know this one. This one I'm going to have to use my calculator for, so I'll pop over. I'll do inverse cosine of 1 divided by 6, and I get 80.4, and since I just told you to round to the nearest, it's 80. It's in the first and fourth quadrant, so 80 is one of my answers. Hmm. 80 is one of my answers again. And then, let's see, 360 minus 80 is 280. 280 degrees. Yes, that makes sense. Comma. Now, let's see, when does cosine equal negative 1? Cosine equals negative 1 halfway through this curve, and that's at 180 degrees. Wow. Rocking and rolling. All right, that's it. That is how to use some of the basic trigonometric identities to solve equations. You're going to substitute some things in to make your life easy. Don't stare at the problem. It's not going to help. Got to try something. Throw something in, mix it up, try something. All right, kids. You like the video? Subscribe to the channel. I liked having you guys here. Peace out. Oh, by the way, Algebra 2 and Trig New York State Regents exams are coming. So if you're paying attention and you're watching, those will be coming in the next couple of weeks. We get spring break. I think I'm going to do a bunch over spring break. All right, guys. Peace out, kids. I think it's those keys. Bye. Freeze it.